Okay, over there, where it says introduction to graphs. Now we have done some graphs already. Okay, we've done vertical and horizontal lines. The types of straight lines that we're going to do now are the skew ones. Okay, the ones that aren't perfectly vertical or perfectly horizontal, they obviously are a bit more complicated than the ones that we've done so far. All right, so we are going to fill some stuff in on this page now. All right, they're saying for each of the examples below, I'm going to do the first one with you, then you're going to do the next one on your own. For each of the examples below, complete each table of values for the given equation. All right, so if we're looking at number one here, they have given us an equation. Do we see that this is saying y is equal to x plus 2? That is an equation. All right, now guys, this equation that we have here is actually the equation of the straight line. So let's just add that in. This is an example of an equation. Just put new ink in there quickly. Equation of a straight line, you can just write there. Okay, then we are going to plot the points showing the relationship on the given set of axes. So guys, do you see that they've given us a y-axis? There is a very small y printed there next to that number 5. And they've given us an x-axis. Okay, there's a very small x. Here they've given us the Cartesian plane, or they sometimes call it a set of axes because there's an x-axis and a y-axis together. Okay, so it's like a set. So that's what they're saying there. Guys, what do we remember about points? Points always look a certain way. How am I going to write a point? I always use a bracket, then x, the x value of that point. Then I use a semicolon. Then I'm going to write the y value of the point, and then I'm going to close my bracket. Okay, so they are saying that we're going to plot the points showing the relationship. The relationship here, we're going to discuss it now on the set of axes, and then we're going to describe the shape of the graph next to the graph. Okay, so we're going to write down what kind of graph we are given. All right, once we've done all of that. Now guys, you might remember working with tables in grade 8. I don't think we've worked with tables in grade 9. I can't remember now. All right, but they give you an input value, and then you must find the output value. Does that sound familiar? You've also worked with flow diagrams in the past, all right, where the input value is the one that goes into the box. There's something happening in the box, some kind of operation, then the output value is the one that you get there. Now guys, if we're looking at this equation, y is equal to x plus 2. Let's look at what they've given us in this table. They've listed some x values over here. Now, if x is -3, I'm going to use that in this equation to get my y value, because this equation is saying that y is equal to whatever my x value is plus 2. Now, what is -3 plus 2? -1. Good. So when my x value is -3, according to that equation, my y value is going to be -1. Then we look at the next x value. If my x value is -2, my y value is going to be -2 plus 2, which is 0. So the x value is the input value, guys. Your y value is the output value. Okay, that's what we're getting out when we put that x value that they've given us into our equation. If my x value is -1, y is going to be -1 plus 2, which is 1. If my x value is 0, y is going to be 0 plus 2, which is 2. If x is 1, y is going to be 1 plus 2, which is 3. If x is 2, y is going to be 2 plus 2, which is 4. If x is 3, y is 3 plus 2, which is 5. And for the last one there, if x is 4, y is going to be 4 plus 2, which is 6. Now guys, what you are supposed to see here is that in this table, we have pairs, an x value and a y value that will go together. All right, if my x value, like we said for the first one, if my x value is -3, my y value has to be -1. So these two work together. All right, if I put my x value of -3 into my equation, I get the y value that must go with that x value. So this is actually giving me a point. My x value is -3, and the y value of that point is -1. Okay, for the next one, if your x value is -2, your y value has to be 0. That gives you another point where x is -2 and y is 0. If x is -1, y is +1. So -1 and +1 go together. They are a pair. Do we remember that we call points ordered pairs as well? All right, so those two values go together. If x is 0, y has to be 2. So 0 and 2 will go together. They will give us 1 point. And we do that all the way along. Right? We put the x value and the y value that we get when we put that x value into the equation. That will give me a point. 3, 5 is the next one. And 4, 6 is the following one. Now, these are the points that we have to plot. Okay, so we're going to plot -3, -1. Remember the x value, if that is -3, we go to -3 on our x-axis. All right, just hover your pen or your pencil over there. And then from there, we need to go to -1. And there we're going to plot our point. That is the first point. Okay, next one is -2 on the x-axis and 0 on the y-axis. So it is over there, hey, because on this axis, if we look across, the y value is 0. So that is the point -2, 0. -1 on the x-axis and +1 on the y-axis. So you go to -1 on the x-axis, then from there you go to +1. That is the next point. Are we trying to, or are we starting to see that we're going to get a straight line here? Okay, if we actually connect all of those points in the end, do we see that they are in line with each other? The next one is 0 on the x-axis and 2 on the y-axis. So we start at 0 and then we go up to 2. The next one is 1 on the x-axis. So we go to 1 on the x-axis, then we go up to 3. So 1, 2, 3. You have to kind of guess where that is. Sorry, the grid didn't print very nicely. The next point is 2 on the x-axis and 4 on the y-axis. Okay, we're nearly done. The next one is 3 and 5. And the last one we actually can't plot. It doesn't fit on our grid that they gave us. Right, we can go to 4 on the x-axis, but does our y-axis go up to 6? No. Okay, so that last one, unfortunately, we can't plot, but it's all right. Do we see that these points are all in line with each other? Right, they make like a skew line. Please take a ruler, guys, and connect those points. But just like when we did horizontal and vertical lines, we're going to extend the line past the point and we're going to put arrows on the ends. Okay, so look at what I'm doing. Just taking my ruler, I'm drawing a line going through all of those points. All right, but I am extending the line so that it goes slightly past the 2 points, the last points that we have, and I'm putting arrows on those ends. All right, you always have to do that when you're drawing a straight line or any kind of graph. You're always going to put arrows on the ends. That is just to show, guys, they did actually give us a point that will go further on from this one, right? This point that we have here is 3, 5. But we're supposed to also have 4, 6. It just didn't fit on our axis. All right, and what if they gave us a point 5, an x value of 5? We would have another point. And an x value of 10, we would have another point further on. So that is why we extend our line and put arrows on the ends, just to show that the line won't actually stop at these points. We could have more points. Okay, we're just choosing to not draw them, or the table that they gave us didn't include those points. Okay, what kind of shape does this graph have, guys? Okay, it's not a trick question. I've said it a couple of times. It's a straight line. Good. Straight line. Okay, you're going to do the next one on your own, please. The next one is slightly more difficult because this equation is not just x plus 2 like we had now. Now you're going to have to do 2 things to the x value. Okay, I'll do the first one with you. We see that we're going to say 2 times whatever our x value is, and then we must minus 3 from that answer. So the first x value that they've given us is -3. What is 2 times -3? -6. And then what is -6 minus 3? -9. Guys, you are allowed to use your calculator for this. If you don't trust yourself, you can take the calculator, all right? You can type that equation in 2, put a bracket, put whatever your x value is, so -3, close your bracket because it's 2x, right? 2 times x. And then -3 after that. And then when you press equals, it will give you that answer. Now, guys, if you want to type it in for the next one, I'm not going to clear this. Let's be smart about it. Let's use our arrow button and we move back to that 3. I want -2. So I'm just going to delete that 3 and I'm going to change it to a 2. You know, you can do that on the calculator, right? You can move around and change things that you want to change. There, our next value is going to be -7. Okay, you can work all of them out like that, guys. I want you to fill in the rest of this table. Then you're going to write the coordinates underneath the table like we did here. Then you're going to plot all of those points and you're going to connect them. Okay, so you're doing exactly what we did for the first example. You're doing it on your own, please. What the furthest, the y value, the y-axis. Yeah, so some of it might not fit, but then we're just not going to plot it. Okay. Oh, yes. Sure. Guys, you're a bit unfocused, hey? Can you just You won't be able to plot the first 2 points, all right, because we don't, our y-axis only goes to -5, but that's fine. You can just start by plotting the ones that fit. Okay, guys, let's take a look. Most of you are done or nearly done. All right, that's what I got. So first just mark your table, and then you can look at the points that are written underneath the table, and then you can look at your line. If you haven't finished, you can finish quickly, it's fine. Yes. Just wait for the corner to come back. And you can go. Right, any questions there, guys? We're going to do the one that is on the other side of the page now as well. All right, but I'll just give you a little while just to finish copying that down. Yeah. So the first and second ones didn't fit on the graph because we had -9 and -7, and our y-axis only went to -5. The fourth one, 1, 2, 3, 4, this one, it's over there. So 0 on the x-axis and -3 on the y. Okay, guys, let's look at the other half of this page. It's basically the same thing, but they've asked it in a different way. So they're saying, I'm guessing that was patterns and graphs, and then I punched a hole through the page. There is like a circle there, so you can just put a PHS over there. Sorry about that. Or you can just leave it as well. It doesn't really matter. All right, so now they've given you a flow diagram. Okay. They're not actually giving you the equation of this straight line. They're giving you the flow diagram. And they're saying X, your input value, must be multiplied by 2, and then you have to add 3, and that will give you Y, your output value. So they're saying, can you write an equation that shows how Y is found once you know X? All right, so we're going to say Y. Remember, the output value is always that value equals the whole thing. So Y, the output, is equal to, now how do I write X times 2? 2x, good. So 2x, and then we are adding 3 plus 3. Right, y equals 2x plus 3. Now this is very similar to the one that we've just done, But the one that we just did was 2x minus 3. Okay, this is now 2x plus 3. So we're going to see how this one is different. Please do the same thing, guys. You're going to fill in that table using this equation now. They've given you x values, and then you're going to write your points down and plot them. Okay, this grid is a bit bigger, so I think you'll be able to, yeah, you might be able to fit all of them in, hopefully. Okay, let's take a look. Here we go. So you can check the table there. Oh, sorry, I actually didn't write my points. Let me do that quickly. There we go, yes. I did ask you to do it because that's what we did in the previous ones, but it's okay. As long as you were able to draw the graph, yeah. I just read it off the table as well. Okay, guys, and again, we see that we're getting a straight line, right? So now we're going to look at what these three equations that we use now, what they actually have in common and how we need to be able to interpret them. All right. We're actually not always going to draw a table of values and then plot every single point in that table. All right. We are actually going to work towards a point where we only need to draw 2 points. All right. Instead of how many do we have here? 1, 2, 3. Instead of 7 points. All right. We can actually only plot 2 points. And that will then give us the correct shape of that graph. All right. So we are going to write a note, the straight line equation. Okay, that is the next thing, the straight line equation. I'll zoom out of it. And on this side, I'm just going to write the three equations that we worked with now. So the first one was y equals x plus 2. Then we had y equals 2x minus 3 and y equals 2x plus 3. Okay, those are the three that we've just done. Now guys, do we see that they kind of look similar? All three of those equations? All right, firstly, all three of them start with a y equals. I think that's very obvious to see. Then we have an x term. All right, in the first equation, it was a 1x. All right, do we see that? X is the same as 1x. In the second and third equations, we had a 2x. All right, you'll see later on that this number in front of the x can actually be anything. It can be a 3, it can be a fraction, it can be a decimal. All right, so we've looked at 3 graphs now. In all 3 of them, we had a number and then an x. All right, in the first one, the number was 1. That's why it's not drawn there. Okay, so we see that that was similar in all 3 of them. We have y equals a number and then an x. And then we have a constant term that comes after the x term. All right, remember what is a constant term? It's a term that has no variable, no letter attached to it. Okay, it's just a number. So in the first one, it was plus 2. Second one, it was minus 3. In the third one, it was a plus 3. Now, guys, all straight line equations that are skew ones, right? Because remember, we've done vertical and horizontal equations. Those are different from these ones. All straight lines that are skew, not vertical or horizontal, will have that type of equation. Okay, so we're going to write that down. We call it the standard form. And for the standard form, we are using letters instead of numbers. All right, you'll see now. We're going to say that the standard form of a straight line equation is y equals mx plus c. Now, m and c will be numbers, right? Like we saw here. M is the number in front of x, the coefficient of x, a number. And then c will also be a number. Okay, it can be a positive number, it can be a negative number. Now, guys, before I write down what m and c will actually be always, let's quickly take a look at the graphs that we did again. Let's see if we can find some similarity between the equation and the actual graph. I want you guys to notice that in the first equation, the number, the constant term was positive 2. Do we notice that on this graph, right, it cuts the y-axis at positive 2. It's quite small now, but you can look on your page. You might not be able to see it. but that point over there is at 2. Right? Do you see that? Let's circle that point, please, guys. That is important. We call this point the y-intercept. The point where the graph cuts the y-axis, that specific point is called the y-intercept. Now, guys, what were the coordinates of that point? What is the x value of this point? The x value is 0 and the y value is 2. So this y-intercept has the coordinates 0 and 2. Right? 2 here, the y value of the y-intercept is the same as the 2 in the equation. Right? Do we see that? It was x plus 2. And here our y-intercept is 2. Let's see if the same thing happens in the other graphs. Let's find our y-intercept over here. Remember, the y-intercept is the point where the graph cuts the y-axis. Let's circle that point, please, guys. Do you see that it's at -3? This point here, so y-intercept is 0, -3, right? The x value of that point is 0, and the y value is -3. And guys, isn't that the constant term in this equation as well? This equation is y equals 2x minus 3. The constant term is -3. The y-intercept is at -3. Yes. Yes. Yeah. Do you mean if they're giving you the graph that's drawn? Oh, well, you will either have to be able to read it off or you can use the equation to find it. It depends on how the question is asked. Okay, guys, let's look at this one. This equation is y equals 2x plus 3. So the constant term is +3. Do we see that our y-intercept is at +3, right? 1, 2, 3. If you count your blocks, that is again the y-intercept. And the coordinates of that point are 0 and 3. So in all 3 cases, right, with all 3 of these graphs, the constant term in the equation is the same as the y-intercept. And that will always happen, guys, with a straight line. Okay, so our c value, the constant term in this equation, we call our c value. That will give us the y-intercept of the straight line. And the point will always have those coordinates. The x value will always be 0. And the y value will be whatever c is, whatever the constant term is. So you're going to have to memorize that, guys. All right, you're going to have to remember the standard form is y equals mx plus c. The c value, the constant term, is always the y-intercept. Okay, m we are still going to work with a lot. So I'm just going to write down what it is now, but I'm not really going to explain it because I don't want to confuse you. But let's just write it down. M is going to be the gradient or the slope of the line. All right, we're going to spend a lot of time working on what this actually means. So you can just copy it down for now. Don't worry. I will still explain it in detail. I'm giving you a formula that we're going to use to calculate M if we need to. Change in y over change in x. Like I said, I will explain all of this in detail. I'm just writing on the side here. In order to use this formula, we need 2 points on the line. But again, guys, we are going to come back to this later on. And just one other thing, if your gradient is positive, your line will look like that. And if your gradient is less than 0 or negative, your line will look like that. So you can just write that down for now. Okay, we don't have much time left, so I'm not going to go into more detail now. I am giving you some homework for Friday. So it's from the revision exercise, it's not a lot. On page 173, I want you to do numbers 2, 5, and 7. In number 2, you're just going to be filling in a table. All right, they're giving you the equation and the x values. You're just going to fill in the y values like we've practiced. In number 5, you must just read off some points. You're going to have to write the coordinates down. Remember how to write a coordinate. First the x value, then the y value with brackets around them. And in number 7, let me just see. In number 7, you are going to, I added it to the instruction last year, so I think they might have said something different. Just add there in number 7, you're going to have to set up a table and draw the graph. The wording of that question is, okay, yes. I just want to show you guys quickly. For number 7, they're saying, use a table to generate ordered pairs or coordinates, so points, to plot the graph y equals 3x plus 1. So they've given you the equation for x equals 1, 2, 3, and 4. All right, so they're saying you have to set up a table, and they're just telling you you're going to have 1, 2, 3, and 4 as your x values. Okay, they haven't given you the table. In this first one that you have to do in number 2, they've given you the table with the x values in the table. In number 7, they're writing down what the x values will have to be. So you're going to do this, guys. You're going to have x and y. X is going to be 1, 2, 3, and 4. And you must calculate your y values using that equation. Okay, that's what you're doing there to generate that table. Then without any calculations, use, what's going on here? Okay, so you're going to find these points, then you're going to plot the graph. Okay, so you're going to have to draw your own x and y axes. So you need to practice to do that again. Then without any calculations, use the graph to read off at least 2 other coordinates related to the same equation. All right, so once you've drawn your line, you need to see if you can read off any other 2 points on your line, points that you haven't plotted already. So for example, if we're looking at this third one that we drew together, right, can we read off any points here that we haven't plotted? What about this one there? What would that one be? It's in line with -4 on the x-axis and -5 on the y-axis. So this point will be -4, -5. Right, so that's what they want you to do on your line that you've drawn. Okay, once you've drawn your line, you need to find 2 other points that you can read off on this line that you didn't plot originally. Okay, so see if you can do that. So you're doing 2, 5, and 7 from the revision exercise. Okay, there are 5 minutes left. Maybe I'll just put this on the board. Do you guys want to take a picture of these questions? So that's number 2. You just want to take a picture of that quickly. And you don't actually have to use your textbook. Okay, number 5. I'll go up to 7 now again. There's number 5. So number 5, they've given you points A, B, C, D, E, and F, and you need to write down the coordinates of those points. All right, so I want you to write A, and then next to A, you're going to write the coordinates. Then you're going to write B, coordinates, C, coordinates. Okay, for all of them to F. And then there's 7. You might have already taken a picture of 7, but there you go. Yep. I will just now. Are we all done here? Which other one? Hey guys, that's homework for Friday, right? I don't see you tomorrow, so please, you all need to do this. Yeah, we have 4 minutes left, so you can pack up if you want.